Welcome to this video. My name is Thomas Roncher and I am a program manager in the Azure Stack Hub team. Today, I'm going to be joined by Aure, who is also a program manager in the Azure Stack Hub team. And together, we follow up on some of the announcements from Ignite 2020 for Azure Stack Hub. Our customers are in the middle of their digital transformation and increasingly adopting cloud-native technologies. In fact, the current situation has increased the velocity in which new technology is adopted. Most enterprises have hybrid strategy, meaning their workloads span across public clouds, on-premises, and to the edge. In some instances, customers even need the capabilities to run their cloud workloads completely disconnected. The reasons for hybrid cloud are mainly the compliance with regulatory requirements, external or internal, low latency sensitive workloads, or the operation in remote locations with limited or intermediate connectivity. Companies across industries like manufacturing, energy, health, and public sector depend on technology to visualize and slice highly dense images for different purposes. But behind it is the same technology. They deploy and manage applications across different sites using container technologies to simplify IT operations, reduce time to market, and improve reliability at the same time. Another challenge many customers face, including manufacturing, is the reality that they store data in different databases across all their locations and even across different cloud providers. This makes it almost impossible to manage and secure the data or even ensure their integrity, provide business continuity to meet industry-specific SLAs, even in the most challenging environments. In this video, we demonstrate how a manufacturing company does leverage a virtual desktop infrastructure to make the front-end application available to their workers. This front-end application uses GPU-enabled virtual machines on a VDI farm for visualization of parts. The middle tier application is deployed using a container from Azure Container Registry to an AKS cluster running in Azure Stack Hub. The application analyzes each part in detail and matches it to the current assembly line configuration stored in a SQL database. While all the above services are running on-premises in Azure Stack Hub, the Microsoft SQL database is hosted in Kubernetes pods and managed by Azure Arc enabled data services. To provide business continuity in case of a disaster, Azure Site Recovery is used to protect various supporting services running in virtual machines that allow failover to Azure, including failback to Azure Stack Hub. Scenario 1, virtual desktop infrastructure using GPUs. Many companies across different industries use software that does leverage DirectX for graphic rendering. For example, in manufacturing to design parts which are later built on the assembly line. By using virtual machines with GPUs, they can replace large workstations with a more on-demand approach and consolidate end-user terminals. With the elasticity of cloud computing, the number of virtual machines can be scaled up and down based on the actual need and only get charged based on consumption. Today, we also showcase Teradigi's Cloud Access Manager, which enables highly scalable and cost-effective cloud access software deployments by managing cloud compute costs and brokering PC over IP connections to remote Windows or Linux workstations spanning various environments. Let's start the first demo.
I am connected to the Azure Stack Hub user portal. You can notice that by looking at the branding on the top left, but also at the URL, which indicates this is running in my local data center. I have already provisioned Teradigi's Cloud Access solution. You see the resources here, but also let me show you a already provisioned virtual machine. As you take a closer look at the virtual machine size, you notice it does make use of a GPU. Next, let me show you how you can provision a virtual machine in Azure Stack Hub. There are multiple ways to provision resources in Azure Stack Hub. One way to provision is using an ARM template. For that purpose, I'm going to use the built-in template editor. Let me show you Teradici's ARM template and how to deploy that. So I'm taking the JSON code, putting that into the template editor, and next we're having to provide various parameters. Let's start by creating a new resource group. I'm also providing a username and a password to authenticate into the operating system. Next, we're having to provide some template-specific parameters. One, for example, is the license key used for the Teradigi solution, but also the license server IP address for NVIDIA's license server, which has to be deployed in the environment. The ARM template also takes care of installing the NVIDIA graphics driver. So let's start by putting in the NVIDIA license server IP address and the license key for Teradigi solution. And last but not least, we're providing the so-called artifacts location that is used for installing Teradigi's agent. Next, the template gets validated and the deployment can start. While this virtual machine is provisioning, let me show you Teradigi's Cloud Access Manager. Teradigi's Cloud Access Manager allows you to generate pools, and those pools can run across various environments. For example, you see I've already provisioned a pool of resources that runs in Azure and a second one that runs in Azure Stack Hub. Cloud Access Manager allows me next to associate workstations with those pools and manage the users having access to those resources. Next, let me show you Teradigi's PC over IP client. Let's connect to a virtual machine. I am now connected to a virtual machine using Teradigi's PC over IP client, which enables, together with the Azure Stack Hub GPU capabilities, this rich remote connection experience. I have opened up the DirectX diagnostic tool to show you that the GPU is present in the system. To demonstrate you how performant that solution is, I'm going to switch this into full screen mode and launch Superposition Benchmark to show you the performance. As the tool is launching, I want you to pay attention to the frame rates per second the system is capable to deliver. As you can see, the system is able to deliver a high frame rate in a remote session. In this demo, you have seen how Azure Stack Hub with GPU support does meet the most demanding application requirements.
I'm handing now over to Garvita to walk you through scenario 2.
The next scenario we'll talk about is deploying a container from ACR to AKS. One of the biggest challenges that companies face is deploying and managing their applications across different manufacturing sites. Kubernetes provides a standard abstraction for their container orchestration, but how do they create and manage these clusters on-prem with ease and confidence? Azure Stack Hub is solving these challenges for our customers by bringing both Azure Kubernetes Services, AKS, and Azure Container Registry, ACR, to our platform. These services also offer you one support path from your hardware all the way up to your container platform. The combination of AKS and ACR allows for a secure integration between customer-provisioned ACR container registries and AKS-deployed KA clusters, making deployment, updating, and managing the container images and KA clusters simple and quick. The following demo shows how a customer can create and manage container registries and Kubernetes clusters using ACR and AKS RPs on Azure Stack Hub. and then deploy a solution on an existing KA cluster from images on a local container registry. First, we'll deploy a container registry using Azure CLI. I've previously created other container registries and imported the images that I need for my application. But if I wanted to import a new image to this registry, I can do so by using the ACR import command, just like I do in public Azure. In order to view this registry and the others that I have access to, I can use the ACR list command. I can also see the images that I've previously imported by running the ACR repository list command. Now that I have a local container registry and I've imported the images that I need for my application, I need a Kubernetes cluster to deploy them to. Let's create an AKS cluster using the same CLI. Now, this could actually take a while to complete, so in the interest of time, let's see if there's an existing AKS cluster that I can deploy my application to. As it turns out, I have another AKS cluster that's available to me to deploy my application. Before I deploy the app, I need to connect to the cluster. First, I'll get the credential for the KA cluster using the AKS get credentials command. Now let's verify if we have connectivity. Since our deployment is pulling images from our local ACR registry, we need to add a Kubernetes secret with the service principal ID and secret that has access to this registry. This allows our Kubernetes cluster to pull the images that we need for our deployment. Let's review our deployment.yaml file before we deploy our application. Notice that we have the secret listed in the file for authenticating against the container registry, and that we are pointing to a local repository and registry. Now, let's go ahead and deploy our app. Let's see how our deployment is going before we move on to the next topic. As you can see, the pods have requested the image and are starting up, and the service has already started. In scenario 3, we'll cover how to manage SQL via Azure Arc enabled data services. One of the services that are highly requested by our customers is the simplification of database management. We are now offering SQL as a PaaS service on Azure Stack Hub. Developers like the simplicity of having SQL as a PaaS service, which streamlines their development practices. It's also highly requested by database administrators who have to focus on the deployment aspects. In order to streamline the experience for developers and database administrators, we are introducing the option to manage SQL via Azure Arc enabled data services running on Azure Stack Hub. Now, the whole app deployment, storage, compute, networking, ID could be achieved all on one stack. This offering will extend the Azure Data Services support for Azure to Azure Stack Hub and will provide a consistent Azure experience on different control planes, such as the Azure Data Studio. The patch and update is managed automatically by Arc, and there's both connected as well as disconnected experiences through setting up your local ACR instance. Azure Arc enabled data services on Azure Stack Hub will enable a hybrid database platform and leverage the underlying platform already offered by Azure Stack Hub. In the following demo, we'll deploy an Azure Arc enabled data service on Azure Stack Hub and then create a SQL managed instance. We'll also show an existing deployment where more than 100 SQL managed instances are already deployed. First, let's begin by logging into our KA cluster. Now, before deploying our data service, let's connect to our private registry using a Docker login command. Now, we should have everything we need to begin our deployment for our Azure Arc enabled data service. We can go ahead and use the AZ Data Arc create command to start the deployment. Now I'll follow the prompts on my screen to create a username and password. Now, as you can see, the deployment has started. While this deployment is underway, let's switch to a different session to make sure the creation is pulling from a private registry. Now in this new session, let's see how our deployment is going for our Azure Arc enabled data service. Here I'll use the kubectl describe pods command. As you can see, the deployment is underway and it is pulling from our local registry. In our second demo, we'll create a SQL managed instance. For this, I'll use another environment where the data controller has already been installed. First, let's go ahead and connect to the Kubernetes cluster's master node. Now that I'm connected to the master node, I can log into my data service using the AZ data login command. I can now go ahead and create my managed SQL instance. I'll follow the prompts on the screen to set credentials for the SQL instance. Now, while the SQL instance is deploying in this session, let's switch to a different session to view our deployment. From my new session, I can run a command to see our newly created SQL instance. As you can see here, the SQL instance is being created. We also have the external endpoint listed here. You can use this endpoint to connect the SQL instance with Azure Data Studio. It is possible to deploy and manage data services on Azure Stack Hub in self-service mode, where the operators can create and manage Kubernetes clusters and the data services, and the tenants can create and manage the SQL instances. In this Azure Stack Hub, for example, we have created over 100 SQL managed instances. The last thing I want to touch on before concluding this demo is Grafana. You can use this to manage and monitor the performance of your clusters, nodes, pods, as well as your SQL instances. Now I'll hand it back to Thomas to discuss our fourth scenario.
Thank you, Garvita. Companies use Azure Site Recovery to build their business continuity and disaster recovery strategy wherever this is possible, and the workloads do allow it. Customers across industries have used Azure Site Recovery in Azure as a failover target for virtual machines running in Azure Stack Hub. This Azure service does ensure workloads hosted in virtual machines on Azure Stack Hub are replicated and available in Azure when an outage does occur. Today, we are introducing a set of scripts that will enhance the Azure Site Recovery protection experience in Azure Stack Hub. These scripts enable a simplified failback experience from Azure by automating the process and removing the manual steps required after failover. This is intended to improve the process and enable a better experience when doing a failback to Azure Stack Hub and reconfiguring the replication. Let me walk you through the scripts.
We are now logged into the Azure portal, and you see various resources associated with virtual machines. Here you see the virtual machine has 3 virtual hard drives. Now let me show you the 3-step script to simplify the failback from Azure to Azure Stack Hub. The first part is actually copying the hard drives to Azure Stack Hub. Depending on the performance of your connection, but also the number of drives and the size of the hard drives, this can take time. Once the script has finished, you will see those virtual hard drives showing up in Azure Stack Hub in the storage container. Here you see those 3 hard drives associated with the virtual machine in Azure Stack Hub. The next part is to create an ARM template out of the virtual machines running in Azure. Now we're moving to the third step, which is the final step, that is creating a new resource in Azure Stack Hub using the just generated ARM template pointing to the virtual hard drives that we just downloaded from Azure. Once this process is finished, you see the deployment succeeded. And now we're having the virtual machine running back in Azure Stack Hub.
We just walked you through 4 scenarios that showcase the new capabilities introduced for Azure Stack Hub.
We're excited to see what you're going to do with these new capabilities. Thank you for watching the video.